All right. Hi, my name is Allison Kunz, and I am a solutions engineer with Hasura. Today we're going to talk about modernizing application development with Planetscale GraphQL and distributed SQL. And we're going to take a look at what it takes to bring a GraphQL service to production, focusing on performance, security, and reliability. So the stars of today, of course, are going to be the Hasura GraphQL Engine and distributed SQL, for example, DB. Hasura GraphQL Engine offers real-time GraphQL APIs with built-in permission systems, cell-level security, lightning-fast performance, and comes with CRUD and other operations done for you out of the box. It works seamlessly with Postgres-compatible databases, including DB, and handles things like read replicas with just an environment variable. So with Hasura GraphQL Engine, you can get a GraphQL API out of the box from your own existing databases. Postgres, we've just introduced MySQL support and a preview of SQL Server. So definitely come and talk to us about that. We are focused on enabling our customers to have data federation. So including data from all of their different data sources, not just their own owned Postgres or other databases, but coming in or bringing in third-party services, both services from other teams and all sorts of data types. And of course, we want to offer complete extensibility, being able to customize the business logic, data transformations, all those things you need to really power your data-driven applications. So let's take a step, like a half a step back. Why are we even talking about GraphQL? GraphQL is an API spec, just like REST or SOAP. It was first created by Facebook, open sourced in 2015, and is now guided by the independent GraphQL Foundation. It's data source agnostic and increasingly popular with several mature server frameworks and clients supported by an enthusiastic community. So why the enthusiasm? GraphQL set out to address a number of structural challenges with REST APIs, especially with highly interconnected data and mobile applications. A GraphQL service starts off with a schema, a typed mapping of your data objects, describing their fields and their relationships to other types. Based on this schema or this mapping, GraphQL can offer introspection and validation. And that powers amazing developer tools like automated documentation and auto-suggest while writing queries. So then GraphQL services allow you to customize and shape the data response without supporting like this vast multitude of endpoints and versioning. This cuts down on data transformations that have to be done on the front end, making developers happy and more productive, and eliminates overfetching of data, which means less data transferred over the wire and happier customers, especially with mobile. Finally, GraphQL frameworks are mature enough to have automated a vast amount of the API development and maintenance work. It's reduced a lot of friction on both the front end and the back end, supporting modern data-driven services. Here are some resources for learning more. And definitely, if you haven't, check out the demo GraphQL API with Star Wars data. It's supported by the GraphQL Foundation. So now that we know that we want the UX and DX improvements provided by GraphQL, how do we go about setting up a service? The Hasura GraphQL Engine is an open source solution that provides a full-featured API out of the box. So instant accessibility for any Postgres database. It also provides a data federation platform to bring together data from all of your different sources. So REST, GraphQL, serverless logic, anything. With Hasura, you can pull all of your data sources together into a seamless, single, unified GraphQL API. So why would you use Hasura GraphQL as opposed to maybe other services? It really comes down to how it works under the hood. And so it's worth taking another step back again and looking at the journey for a GraphQL service from the beginning. This helps to explain how Hasura GraphQL Engine can provide this great performance and extensibility. So if we take a look at a simple query, listing artists and their albums, a very naive approach to providing the data for this query is to query the database for the list of artists, and then querying again for the lists of albums for each of those artists. If there are n artists, then there are 1 plus n total database requests to resolve this query, hence the n plus 1 problem. The first popular approach to solving this problem was to implement a data loader service. So that batched the n album requests together into a single request. This was a massive improvement, and it was very commonly used. However, if we start to look at queries with growing complexity, we can see that this problem presents a real challenge to most real-world applications. The naive approach gets exponentially expensive as queries get more and more nested, and the data loader approach reduces to linear growth, but it's still not really a satisfactory solution. So from a DBA perspective, the query that we have actually looks extremely simple. Your SQL database owner would take a look at this query and the GraphQL query performance and wonder why on earth you thought that this GraphQL stuff would ever be a good idea. And they'd have a very good point, right? The performance is inferior. Let's take a look at what it might take from a SQL perspective to provide the data for that query. It's not a complicated query, and SQL already has ways to optimize the execution and response. So what would it take to have this query instead? And that's exactly what the Hasura GraphQL Engine does, and why its performance is so blazing fast. The query is parsed and then compiled into a SQL statement, which Postgres can handle easily with its decades of experience and optimizations. Perfect. The compiler-based approach lends itself to other interesting opportunities as well. Hasura also built in an authorization engine that can apply session variables and permissions policies to queries before they even hit the database, securing your data at the service level. So you still get things like your real-time connections, you still get all of your separate responses, and it's still secured with the permission policies, but with the batching, much more efficient, scaled incredibly well. The Hasura GraphQL Engine also has access to two important parts of this process between GraphQL query and SQL execution. First, there is the compilation process we just talked about, which here we're going to lump together under the Hasura umbrella. Then Hasura can also instruct the Postgres instance to use prepared statements, which captures the work done by Postgres to convert a SQL statement from Hasura into an actual execution plan. This results in an incredible boost of performance at scale. You can also see how the core design of the Hasura GraphQL Engine would make it easy to keep adding extensions. Since few companies rely only on the data within their own Postgres databases, we focused our engineering efforts on data federation, providing multiple ways to bring in your important data from other company divisions, legacy systems, and third-party services, regardless of their API frameworks. Finally, you can also bring in business logic or data transformations, or trigger event services for tasks like new user emails or monthly cron jobs. Hasura can bring together your application's data sources, security controls, and business tasks seamlessly into a single GraphQL API. This also is pretty unopinionated for what it does. So Hasura GraphQL Engine allows you to have kind of your choose your own adventure in terms of deploying these services. So with authorization, we work with pretty much any web token or auth-hook configuration, any cloud provider or any of these major services. We are increasing our database options. So anything Postgres compatible, so timescale DB, gigabyte DB, works out of the box. We are adding MySQL support and we have a preview of SQL Server. And we are open to, we have a big roadmap of more and more databases that we want to support, and welcome, your input and assistance in adding these additional capabilities. And of course, with extensions, our actions or events, anything goes. So actions and events, anything with an endpoint. So you can write it, you can use a server, or you can use serverless functions. You can write it in anything. Basically, the service should just expect an input of a specific type, and it should be able to either, for an event, run the action as expected, or for an action, provide the response in the typed format expected. However you want to do things, bring in REST APIs, add business logic, run your data transformations before you hit the server, anything is possible. Of course, with distributed SQL, we have these wonderful services that can help us do global deployments, and our data can be everywhere. But you want to have a GraphQL service, so your GraphQL server also has to have that kind of scale, and also a lot of other capabilities and checkboxes handled before it is really production worthy to get this, to enterprise grade. So let's talk about what that looks like. How do you have this kind of large scale GraphQL API that everyone can use? So this is the goal, right? You want to have your databases and the GraphQL API services ideally co-located and distributed globally, depending on your needs and your customers. And of course, you want it to be scalable as well, more or less according to the needs of the customers and cost considerations. So let's take a look at these checklists. GraphQL in production does have, or any API in production, there are a lot of tasks that need to be taken care of before you ship. So we're going to take a look at performance, security, and reliability. So performance. We're going to ignore the first two tasks on this list, since Hasura's CRUD performance is already pretty awesome. We're going to consider that taken care of. We're going to focus instead on caching and scalability. Because GraphQL queries are so customizable, caching is a hard problem. Different frameworks and teams have come up with different solutions, and it matters what kind of data and what kind of security requirements are involved. Generally, you'll need to implement caching for your GraphQL service with a way to use that cache from a request. Because of the way Hasura Cloud is set up, it can provide extremely efficient caching by combining strategies A and C on this list. We won't get into details today, but I'll include a link to a more in-depth, exhaustive summary of the conversation at the end of this talk. So scalability. So next, we'll want to make sure that there are read replicas, scaled architectures available for your production instances of Postgres. We'll also need to make sure from the GraphQL server standpoint that load balancing and connection pools are in place. And for example, routing, so mutations are only routed to master. So how much work are we looking at with these requirements? We know that caching is just hard. With the Hasura GraphQL Engine, that's the only challenging item remaining on this list for you to take care of. The rest is handled by Hasura's expertise that they have packaged into the Docker image. With Hasura Cloud, we can also skip even that, and we can use the @cached directive right out of the box. So we're going to move on to security, securing our production API. These are actually the same tasks required for any kind of API, and many of them are very well known and straightforward. So securing the API. Nothing surprising here, you've seen this before. The only challenging part here might be team management, allowing certain people specific levels of access to the service admin and tools. You don't want to pass around an admin secret throughout your entire company, probably not a good idea. And you want to make sure that some people can see maybe some sets of data, some settings, some permissions, but maybe not everyone. You need to know only. So we'll see how Hasura Cloud manages these things in just a moment. Authentication. The major GraphQL frameworks all offer ways to configure tokens or webhooks for authentication. There are detailed guides for adding most of the major auth providers in the Hasura documentation, so definitely take a look. Also of note, if you do enable the authentication mechanisms, you will have to specifically tell Hasura to have or to allow an anonymous role, and you'll have to set those permissions by table, just like you would another user role. Next, you'll want to review your permissions, roles, and rules for data access. One thing to remember is that, Hasura does ignore unauthorized users by default if authentication is set up. And you'll want to review both the summary and the by action details for all of your user roles. For example, you see here that we can set things by select, insert, update, or delete. We can also limit maybe the number of rows sent back or allowed in the response. And we can also take away or add the ability to do aggregate queries. By setting limits to access, you can also prevent a lot of possible mischief or common mistakes. The Hasura GraphQL Engine offers allow listing and ways to add response limits to permissions policies. Hasura Cloud can also manage rate limiting with a convenient UI. We can see that securing our API does require a lot of work. What's nice is that the Hasura GraphQL Engine has prepackaged a lot of this work for us. And also Hasura Cloud also provides the rest. One last section, and then we'll get to the demo. How do we know that our API is performing well? And if it isn't, how do we troubleshoot quickly? Most GraphQL frameworks provide a health check API. You just need to integrate with a service. Observability is critical when anything goes wrong. Again, these steps are pretty standard for any kind of API, and you can continue to use your tools of choice. Before adding changes to your staging or production environments, you'll want to ensure that the GraphQL operations required by your application still work as expected. Checking changes on dev or staging before promoting to prod will prevent any accidental regressions. Finally, for applications with strict availability requirements, container load balancing and failure recovery setups will be necessary. Similarly, you can configure high availability mode for Postgres on your chosen cloud. Also works great with Gigabyte. We can see here that reliability involves a fair amount of work, tedious work, regardless of framework, since it's tied to deployment rather than internal. Our experts at Hasura Cloud make sure that your Hasura instance is deployed with best practices and reliability in mind. Let's take a look at Hasura Cloud to see these features in action.
Here's a sandbox project I have with Data Federation. Let's start with the Data tab. This is a music application with playlists that people can review and get more suggestions on what playlists to listen to next. These tables are in a Postgres instance on Heroku. Going back to the Explorer, we can see that there are even more types of data available than what we had in Postgres. These items are assets are actually from a remote schema, a Graph CMS instance where an item is a single review. and an asset is an image. We can access these types just like we can music or album from Postgres. Let's see how it works. We have a number of options for adding a remote schema. Let's take a look at the GraphCMS one we've already made. We have the GraphQL endpoint and the authorization header. That's all we needed to connect a new data source. Let's see the editor. Note that we can forward the headers from the original request and include new ones from static values or environment variables. Since this is a review of the playlist, I've added a remote relationship to the playlist. I've specified the remote schema. I've configured item where ID is equal to the review ID. From the row. And if we go into the graphical tab, playlists, reviews, and then we have our reviews. So let's also take a look at our action, like we saw before, suggested playlists. Again, we just need the definitions, the handler. We can forward the client headers, so we don't have to specify the user ID in the query. We can let that be handled by the header. And we can also add a machine learning service secret key from an environment variable to help keep things secure. We add a relationship. So we have object and array relationships, so one-to-one or one-to-many. We can name the relationship. We can specify the schema and the table that it's referencing. And we take from playlists in this request, it goes to suggestions on the playlists table, which is a JSON-B field we've already specified. We can also specify permissions. In this case, the user is allowed to see these permissions, but anonymous users cannot. By the way, we do have some really handy code gen already built into the system to help you with writing those handlers. And you can see that we keep adding more and more languages and formats. So again, going to the graphical instance, we go back to playlists, and we have suggestions that we can add. There we go. All right. By the way, please check out on Hasura Cloud our Pro features, where we offer analytics, we can drill down to specific operations as well, with complete information from the operation string to the response size. We also have tracing information available. We can see that this was actually a cached query. And we see the execution time is extremely fast. Yeah, from 84 milliseconds to 3. So it worked. Perfect. So for errors, we can also drill down to the specific error message. Incorrect query. So we've been looking at queries, but we can see the same information for subscriptions. Looking at an individual subscription worker, perfect. Hasura Cloud provides an easy UI to review and manage your allow lists. You can remove operations, export your allow list, and add new operations from a list of recent activity. There's a similar interface for adding API limits. You can edit existing limits, request per minute, by unique parameter, operation depth limit. Or you can create new ones. Regression tests too. You can view and edit existing operations in the test suite. Or you can add new items from recent activity. You can run tests manually, or you can add them to your CI/CD workflows. You can also see the results of past runs.
For more technical information and detailed examples, please take a look at the Hasura docs, our blog posts, and our YouTube channel. We're also available on Discord. We have a very active community with over 7,000 users and promoters, and of course, the contact form on our website. All right, hope that was interesting. Thank you very much.